All right, guys, let's keep going. Remember, this is 8th grade math, unit 4, lesson 13, and this is part 2 video. And it's slide 7 in your assignment. Read the directions. Here are 3 systems of equations graphed on a coordinate plane, A, B, and C. Question number 1, which graph matches the system of equations? Okay, well, in order to answer these quickly and easily, please remember the golden equation y equals mx plus b. Don't forget that b equals the y-intercept. And m is slope. Don't forget that because that'll make this really easy. So looking at these two equations, y equals 3x plus 5, we see that the slope is 3 and the y-intercept is 5. Y-intercept is where it crosses the y-axis. It's equal to 5. And we see that the y-intercept of this line is 20. I don't need to make a table of ordered pairs and plot it to figure out which graph it is. I'm going to look at the y-intercept of these lines. I'm looking for a system of equations where one of the lines has a y-intercept of 5 and the other line has a y-intercept of 20. And that could only be this one. Look, y-intercept of 5, y-intercept of 20. And just to be sure, let me check the slope. This line has a negative slope. Where there's a y-intercept of 20, the slope is negative? Yeah. In the line, the slope is -2. So that matches. None of these other ones have a y-intercept of 5 with a slope of -2. Okay, now, I'm sorry, I mean a slope y-intercept of 20 with the slope of -2. Here's the y-intercept of 20 on the other graphs, and there isn't a line through that point. And then double check where we have a y-intercept of 5, we see this steep positive slope, and that corresponds to the slope of 3. So using the golden equation y equals mx plus b, it was easy to find the system of equations with these y-intercepts and those slopes. So it must be graph A. Okay, number 2, by looking at the graph, what is the solution to the system? Please remember what we mean by a solution to the system of equations. It is the x and y value that make both equations true at that point. And you'll see that on the graph where the lines intersect. Let me circle that. Okay, so I'm supposed to, by looking at the graph, find the solution. Oh, I'm going to estimate. Okay, looks like x is 4, I guess. Looks like y is, I don't know, 12. I mean, I'm just guessing by looking at the graph. So I'm going to put a big maybe. Dun, dun, dun. That's my guess. Keep going. Next question. Use algebra to solve the system of equations. This is the same system of equations. Now, we're going to solve it with algebra. You looked at the graph, you found where they intersect. That must be where x and y are equal. Let's solve it again using algebra. So at the point where they intersect, y in one equation is equal to y in the other equation. They have the same x and same y value. Because the y is equal to the y, we can say, okay, if y is equal to y, then this equals this. Let me be really clear. Excuse me. So if y equals 3x plus 5, and that equals the other y, which is -2x plus 20, if this equals that, then let's just say, okay, y equals y, then 3x plus 5 equals y. -2x plus 20 equals y. Well, then 3x plus 5 equals negative 2x plus 20. So I'm jumping ahead and I'm rewriting it like this. And that's true because both y's are equal. I forgot my plus sign. There we go. Okay, I want you to write this down because we're going to solve it together. And when I say solve it, I mean we're going to find the value of x. In 3x plus 5 equals negative 2x plus 20, what is x that makes that true? So that's what I mean when I say we're going to solve it. You have to remember the steps to solving equations. So if you don't remember, this is going to be a review. Oops. Step 1, eliminate parentheses. And you can see I still haven't learned to spell that. Parentheses? Step 1, eliminate parentheses. Okay, we don't have any parentheses, so step 1 is finished. Step 2, combine like terms. What I mean by terms, that is the variable terms and the constant terms. I'm going to remind you of those again. Constant terms are just a number like plus 5 and plus 20. They don't change. They're not variable, they're constant. The 5 isn't going to change. Variable terms have a variable in them, like 3x, because x could be 2, 3, 4, 5. So 3x and negative 2x are the variable terms. So let's combine like terms. We want the variable terms on one side of the equation and the constant terms on the other side. To do that, I'm going to start by adding 2x to both sides of the equation. The rule is you must do the same thing to both sides of the equation. And I've already showed that in many videos, so hopefully this is just a review. So I added 2x to both sides of the equation, and I did that on purpose so that negative 2x plus 2x cancels out. When I say cancels out, I mean that equals 0, so it kind of goes away. Then I get 3x plus 2x, that is 5x, and this 5 stayed the same, it didn't change, so keep that 5. Negative 2x plus 2x, that equals 0, but plus 20 stayed the same. I wrote plus 20, but you know what? I don't even need to have a plus sign. It's positive. Let me erase that. Next, I'm going to combine the constant terms. I'm going to subtract 5 from both sides so that this positive 5 cancels out. And then I get 5x equals 15. Okay, combining like terms is finished. The last step is isolate the variable. That means get x all by itself. So I want to isolate the x, but right now it's being multiplied by the number 5. So to isolate, I have to get rid of the 5. I'm going to divide by 5. If x is multiplied by a number, then divide by that same number to cancel it out. And you have to do the same thing to both sides of the equation. So 5 divided by 5 equals 1. 15 divided by 5, that equals 3. So our answer is x equals 3. So now I found the x coordinate for the system of equations. I know that they cross at x equals 3, but I don't know y yet. I'm going to solve for y. Here's how. If the x value is 3, I can substitute in x equals 3 into either equation to find the y value. So I can choose either one, and I'm going to choose the first one just because it looks easier. So y equals 3, and I'm substituting my solution, x equals 3, in here. 3x plus 5, so 3x is equal to 3 plus 5. Let me draw a little diagram here to help you understand what I'm doing. I set both equations equal and I solved for x. Now I'm putting that x value back into either one of these equations with substitution. That just means I put x in here. And now I'm going to do the math and see what y equals. Okay, 3 times 3 is 9, and then plus 5, so that's 14. The y here, I didn't keep writing it, but y equals 14. Ding! Okay, let's see how I did. Remember on the previous problem, I looked at the graph to estimate, and I thought maybe x is 4 and y is 12. Well, I need to read the graph a little more carefully, I guess, because it's really x equals 3, y equals 14. I was a little off estimating. So when you look at the graph, it could be hard to see, but when you do the math, you're going to get the exact answer. Okay, let's do another problem together. Number 1 on the next page, and this is slide 9. Okay, look at your assignment and make sure that I didn't make a mistake. Slide 9 has this one here, number 2, y equals 2x minus 10, y equals 4x minus 1. Okay, remember what I did previously? I just looked at the y-intercept. So this has a y-intercept of negative 10. And the second equation has a y-intercept of negative 1. Which of these 3 graphs has 2 lines with those y-intercepts? Not that one, not that one. Aha, here we are. Y equals negative 1, y equals negative 10. And then look at the slope. This slope is 2. This slope is 4. Yeah, they have those positive slopes. The slope of 4 is steeper. You can see that too. So the line with a steeper slope has a y-intercept of 1. Okay. So the answer is that it's graph C. Number 2, by looking at the graph, what is the solution to the system? Okay, well this is not something I'm good at, is looking at the intersection here. Here's where the lines intersect. And it looks like x equals negative 5. And it looks like y equals negative 15. I don't know, maybe? I'm not good at looking at a graph and trying to estimate those points. So I'll write that in coordinates, negative 5, comma, negative 15. Remember, when you write your points in coordinates, it's x, comma, y, and you have it in parentheses. And I'm going to put a big maybe here because I'm estimating. Okay, next question. Use algebra to solve the system of equations. Okay, here are the same 2 equations again, the same ones. Ding, ding. Now we're going to solve with algebra. Remember what I did last time? We're going to say y equals y. So that means 2x minus 10 equals 4x minus 1. Because here is y equals y. Y equals y, then 2x minus 10 equals 4x minus 1. Now solve for x. To solve for x, step 1, eliminate parentheses. But we don't have any. Step 2, combine like terms. Okay, let's do it. I'm going to subtract 4x from both sides of the equation so that 4x minus 4x cancels out. And then I get 2x minus 4x, which is negative 2x. And I'll keep going a little fast. Look at the 10, it comes down, the negative 1 comes down. Now I want to move negative 10 over to the other side of the equation because I want constant terms on one side and variable terms on the other. So I'm going to add 10 to both sides of the equation so that negative 10 plus 10 cancels out. And I get negative 2x equals negative 1 plus 10 is negative 9. Now isolate the variable. We have to get x all by itself, but it's being multiplied by -2. So divide by -2. Divide both sides by -2. And I get x equals -9 divided by -2. Let me fix my writing there. And that equals, you know what? I think I made a mistake. Oh yeah, my -1 plus 10 is not -9. This should be a +9. Check your notes right here. I had a -9, but it should be a +9. I recognize that I made a mistake because I had a negative divided by a negative, and that would be a positive x. But we already looked at the graph, and we know that x is on the negative side. So I caught my mistake really fast. Okay, so that was supposed to be +9. +9 divided by -2 gives me a -4.5. Okay, x equals -4.5. Now, do you remember what to do next? Now that we found x, substitute x into either one of these equations to solve for y. I'll just use the first equation, but it doesn't matter. You can use whichever one looks easy. Oh, and you have to show your math on your assignment too. So you might not choose the same one as me, but you have to show your math. If you choose the same as me and you're copying me, show all of your steps in the assignment to get full credit. Okay, so y equals 2x, and x equals -4.5, minus 10. Now let's do the math. 2 times -4.5 is -9 minus 10, and that equals -19. So I solved, then I got y equals -19. And look at the graph. Okay, y equals -19. Okay, I'm not that good at reading little graphs, but yeah, okay. My estimate was close. I estimated x was -5, but I calculated x is -4.5. I estimated y is -15, but I calculated, and it is definitely y equals -19. So calculating the answers can give you more accurate results. Okay, there's one more to do that's exactly like that. It is on slide 9 and then calculate it on slide 10. So slide 9, look at the graph. Slide 10, do it again with algebra. That's slide 10. I'm going to let you do those on your own. You need to show all of your work for that, but you know what? I'm going to go ahead and give you the answer. For slide number 10, you better find that x is equal to -10 and y is equal to 7. I expect you to show me the steps how you found that. Okay, we're almost finished. There's just one more question. The last question has 2 lines graphed, and I'm going to highlight them because my printer is black and white, and it'll be more fun to see them in color. Okay, look at these 2 lines and then answer the question. How many solutions does this system of equations have? Explain your reasoning. Don't forget that a solution is where the x and y value are the same. And we see that where the lines intersect. But these lines are not intersecting, they're parallel lines. So is there any point where the x and y value are the same? Well, let's look when x equals 0. So when x equals 0, for the red line, hold on, I think I can make this even better if I use the red line and the blue line. Okay, there. So for the red line, when x is equal to 0, the y looks like, I don't know, +1. And for the blue line, the y looks like, I don't know, -8. Anyway, they're not the same. So when x is 0, they have different y values. That's not the solution. How about when x is equal to 5? Maybe that's about right here, maybe. And it looks like this is, for the red line, when x equals 5, I'm going to write it as coordinates. When x equals 5, there we go. The y value looks like, I don't know, 3? 3? This is the y value. And for the blue line, the y value is like -7? I don't know. So anyway, they don't have the same x and y. If I look at this x value, the y is different. When I look at this x value here, the y is different. At this x value, the y's are different. There's no solution. They're parallel. There's never gonna be a point where they cross and have the same x and y value at the same time. So, how many solutions does this system have? None. Because there is no point on both lines. If there's no point on both lines, then they have no x and y coordinates that are the same. Phew, okay, please read more about the system of equations and mark all of your work in the slides before you turn it in. I need to see all of your work to get full credit. Don't copy my answers. Show your work. Even if it's exactly the same as mine, you have to show it. I want to see that you did it. Bye-bye.